Chapter 3 is called Set Theory and Logic. 3.1 is Types of Sets and Set Notation. So we have to start off with a whole lot of vocabulary. So a set is a collection of distinguishable objects. For example, the set of whole numbers W is equal to squiggly bracket 0, 1, 2, 3, 4, 5, 6, all the way up to infinity. An element is an object inside of a set. For example, 3, the number 3, is an element of W, which is the set of whole numbers. A universal set is a set of all of the elements under consideration for a particular context. It's also called a sample space. For example, the universal set of digits are from 0 to 9. So D is equal to, squiggly bracket, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I close my squiggly bracket. A subset is a set whose elements belong to another set. For example, the set of odd digits, O, is a subset of the digits, D. So O is equal to 1, 3, 5, 7, and 9. This can be written as O is a subset of D. A complement is all of the elements of a universal set that do not belong to a subset of it. For example, O prime would be 0, 2, 4, 6, and 8. That's the complement of O, which is 1, 3, 5, 7, and 9. The complement is noted with the prime sign, O prime. The empty set is a set that doesn't have anything in it. It has no elements. For example, the set of odd numbers divisible by 2 is an empty set. It's denoted by squiggly brackets or O with a line through it. Then we have disjoint sets. There are 2 or more sets having no elements in common. For example, the set of even numbers and the set of odd numbers are disjoint because no even number is an odd number. Let's take a look at an example involving sets. So Jasmine is studying the provinces and territories of Canada. She's decided to categorize the provinces and territories using sets. List the elements of the universal set of Canadian provinces and territories C. So C is going to be equal to all of the things you see on this map. C is equal to BC, Alberta, Saskatchewan, Manitoba, Ontario, Quebec, New Brunswick, Nova Scotia, PEI, Newfoundland, Nunavut, Northwest Territories, and Yukon Territory. So that's C. One subset of C is the Western Provinces and Territories, W. Write W in set notation. Well, the Western Provinces and Territories are BC, Alberta, Saskatchewan, Manitoba, the Yukon, and the Northwest Territories. One subset, yeah, okay. I don't count Nunavut as a Western Territory because it goes all the way over the east over top of Quebec. So, the Venn diagram to the right represents the universal set C. The circle inside of the Venn diagram represents the subset W. The complement of W is the set W prime. Describe what W prime contains. W prime contains all provinces and territories that are not Western provinces or territories. Here's W in set notation. W is Ontario, Quebec, New Brunswick, Nova Scotia, PEI, Newfoundland, and Nunavut. Explain what W prime represents in the Venn diagram. W prime is all of this blue section outside of W, but still within C. Jasmine wrote the set of eastern provinces as follows: Newfoundland, PEI, Nova Scotia, New Brunswick, Quebec, and Ontario. Is E equal to W prime? No, because it does not contain the territories as well. List T, the set of territories in Canada. Is T a subset of C? Is it a subset of W or a subset of W prime? Explain using your Venn diagram. So T is equal to Yukon Territory, Northwest Territories, and Nunavut. It's a subset of C, but it's not a subset of W because it includes Nunavut. And it's not a subset of W prime because it includes Northwest Territories and the Yukon Territory. F. Explain why you can represent the set of Canadian provinces south of Mexico by an empty set. Well, if S is the set of provinces south of Mexico, then S is going to equal nothing or the circle with a line through it, because there are no provinces south of Mexico. Oop, here's my symbol. Circle with a line through it. So, the set is empty. And G. Consider the sets C, W, W prime, and T. List a pair of disjoint sets. Is there more than one pair of disjoint sets? W and W prime are disjoint because no Western provinces and territories are not Western provinces and territories. There is not more than one pair of disjoint sets. Complete your Venn diagram by listing elements of each subset in the appropriate circle. Here's my Venn diagram. So I have my set W, which is the Western provinces and territories. I have my set T, which is the territories. And I have my set W prime, which is all of the Eastern provinces and territories. You can see that the territories overlap the two other sets because you can be a Western territory because you have Western territories and Eastern territories. So communication, notation. The following is a summary of notation introduced so far. So sets are defined using brackets. For example, to define the universal set of the numbers 1, 2, and 3, you list its elements. U is equal to squiggly open bracket, 1, 2, 3, and then you have to close your bracket. To define set A that has the numbers 1 and 2 as elements, you have A is equal to squiggly bracket, 1, 2. All elements of A are also elements of U, so A is a subset of U, written as A is a subset of U. The set A prime is the complement of A, and can be defined as A prime is equal to 3. Because A prime includes all of the other things in U that are not a part of A. To define the set B, a subset of U that contains the number 4, B is equal to an empty set because 4 is not a part of our universal set, U. Here's an example. Sort the numbers using set notation and a Venn diagram. Indicate the multiples of 5 and 10 from 1 to 500 using set notation. List any subsets. So I let n be the set of natural numbers, and then I let s be the set of natural numbers from 1 to 500. So here's s. Here's all of the natural numbers from 1 to 500. Alright, then s is equal to our variable x, such that x is between 1 and 500, where x is part of the natural numbers. So s is a subset of n. This is pretty tricky notation. So I defined a variable, s is equal to x. This straight up and down line means such that. So s is equal to x such that x is between 1 and 500 and x is part of the natural numbers. So s is part of the natural numbers, so it's a subset of n. Because the natural numbers go way past 500. They go all the way to infinity. So s is a subset or a part of n. Let f be the set of multiples of 5 from 1 to 500. F is equal to 5, 10, 15, 495, and 500. F is equal to lowercase f such that the variable f is equal to 5 times x, and we defined x up here. X is between 1 and 500. Then I further define x to be between 1 and 100 because, let's face it, 5 times 100 is 500, so I can't go over and above 500. And I cannot go less than 5. So x is going to be between 1 and 100. But x is within the natural numbers, of course. So f then is a subset of s. Let t be the multiples of 10 from 1 to 500. T is equal to 10, 20, 30, 490, 500. T, my set t, is equal to my variable t such that t is equal to 10 times x. Remember, we defined x way up here. X is going to be only between 1 and 50 this time, because if we take 10 times 50, that gives us 500. We can't go any higher than 50, though. And x is always going to be in the natural numbers. So t is a subset of f, which is a subset of s, which is a subset of our natural numbers. Here's my Venn diagram to illustrate that. So here I have s. I have s. And out here, I have n, all the natural numbers. So then I have f, and then within f, I have t. So here's my multiples of 5, and here's my multiples of 10. There's an example for you involving sets and subsets and notation.